Last year, extreme weather events directly killed over 2,000 people in India. As the effects of climate change drive steady increases in average temperatures, the slums of India have been disproportionately impacted. With over 100 million inhabitants defined as living in extreme poverty, these communities are especially vulnerable to harsh climates. One of the many issues plaguing the inhabitants of these slums is the lack of sufficient infrastructure to protect from the unforgiving Indian climate. Buildings in slums are constructed using heat-trapping materials such as corrugated iron, tin sheets and plastic, leading to 5 to 6 degree warmer temperatures than neighbouring, more developed suburbs. Furthermore, the lack of economic stability and funding renders these communities helpless in the face of worsening living conditions and are hence overlooked by traditional market solutions. The Sphere standards suggest that an appropriate solution lies within effective insulation.
Therefore, our team has developed recycled fibre thermal panels to address this problem. The RFG panel is a sustainable bulk insulation panel created from textile waste such as lint and cardboard. RFG panels work by trapping heat inside the air pockets in the lint. R values are often used to quantify the thermal performance of insulation, whereby greater R values denote greater thermal insulation. The corrugated iron-based structures in India often exhibit an R value of approximately 0.0031. Our RFG panels hope to provide R values of approximately 3.5, similar to that provided by denim insulation.
The RFT panel design was informed directly by the United Nations Sustainable Development Goals, particularly the 3rd and 11th goals, as it improves thermal performance of structures and minimises prolonged extreme temperature exposure. Our solution directly also targets the 12th goal by upcycling textile waste, which accounts for more than 10% of all greenhouse gases globally and is the 3rd largest source of solid waste in India. The relative cost effectiveness and sustainability were grounded in the guidelines outlined by the Equator Principles. To test the thermal performance of our design, 2 scale models were created, using roof sheeting and a timber frame, which are representative of a typical Indian slum dwelling. Only one model contained our RFT panels. The panels were created using a cardboard exterior with a borax-treated lint interior. This ensured flame-retardant properties. These panels were then snugly installed into the timber frame. The scale models were subjected to both daytime and evening ambient temperatures to assess the ongoing thermal performance.
The results showcase stark thermal performance advantages for our insulated scale model. Daytime testing in the heat revealed that the insulated model was up to 4 degrees cooler than the non-insulated model and was far more consistent with the ambient temperature, whilst the non-insulated model grew relatively hotter over time. The evening testing results also revealed a similar outcome, whereby the insulated model was more able to better retain heat. This solution, if implemented on a large scale, has the potential to alleviate the issue of extreme temperature exposure for millions of people in the Indian slums. Slum households can now drastically reduce the energy costs associated with cooling with our easy-to-install panels. RFD panels provide greater thermal comfort for all individuals, in particular those that are vulnerable and disadvantaged, who face greater consequences from extreme temperature exposure. As an added benefit to our solution, the RFD panel manufacturing and installation process has the potential to create jobs for both untrained men and women of all skill levels at several levels of the supply chain. With the textile industry otherwise disposing of fabric and lint as a waste product, we believe that outsourcing such material directly from suppliers would be beneficial to both parties. The ease and cost effectiveness of panel manufacturing means more homes can be quickly improved, hence we strongly believe that there are many job prospects within the RFD panel manufacturing supply chain. The RFD panel design is as adaptable as it is effective. If access to cardboard is limited, properly treated fishnets may suffice to encase the fibre insulation, or if lint is unavailable, old clothes may be reused.
With innovations such as the RFT panel, we at Team Flux hope to improve the quality of life of the disadvantaged peoples of India through cost-effective and sustainable means. Thank you.